Ma'am, please start.
Uh, a very good morning to all. Moving on to our second lecture, today we have with us Dr. Amandeep Singh, currently working as Assistant Professor in Directorate of Extension Education from Guru Angad Dev Veterinary Animal Sciences University, Ludhiana. He has pursued his Master of Veterinary Science in Veterinary Extension Education. He has total 4 years of teaching experience, and during his career, he has handled about 8 research projects, out of which 4 research projects as a PI and 4 as a co-PI. Out of these projects, 7 research projects were extramural funded. He has expertise on the development of information and communication technologies, management of organic waste, including agriculture, household and livestock waste. He is also working on several areas like use of artificial intelligence for early stage animal disease diagnosis, organic waste management through vermicomposting and biogas production. He has published more than 27 research papers, 15 review papers, 5 books, 21 book chapters, 7 invited papers, 11 manuals, 6 copyrights, and many more popular articles. With this word, I would like to invite Dr. Amandeep Singh for his lecture on application of artificial intelligence in optimizing dairy production. Over to you, sir, please.
Thank you so much, ma'am. Am I audible?
Yes, sir, you are audible.
Okay, so I'll be sharing my presentation now. I guess everyone is able to see the presentation and hear my voice clearly.
Yes, sir, it is clear.
Okay, thank you so much. So first of all, thank you so much, ma'am, for wonderful introduction of mine. And at the very beginning, I would like to thank NADCL and Basu Patna for giving me this opportunity to deliberate on a very important and a cutting-edge topic, which is talk of the town, which is talk of the hour, which is artificial intelligence. Like it's been some couple of years since I have started reading about artificial intelligence and working on artificial intelligence, and I have noticed that as far as livestock production is concerned or dairy production is concerned, there are non-tech people who are involved in the development of these technologies. Like, just 5-10 minutes back, I was discussing this thing with one of the DDMs of NABARD also, that we are the technical people who are involved in livestock sector, who are involved in livestock production, be it dairy production or egg production or meat production. But still, this area, this niche of artificial intelligence and the development of technologies related with this, they are developed by non-tech people or those people who are not related to agriculture or related to animal husbandry or veterinary sciences. One reason which I have found that why is it so, because there is very less amount of awareness among us. There is very less sensitization about us. And yes, this is a little bit tough to understand. There's a little bit, there's a difficulty to code new softwares. We need a strong knowledge of mathematics and computer programming. But before delving into this discussion, I would like to tell all the participants that yes, talking about myself, I have learned machine learning from Udemy and Coursera. Similarly, there are so many courses which are available, and you can go online, you can take those courses, and you can learn the languages which are required. Like to go for higher education in English, we need to learn ABC, which is the alphabets. Similarly, if we need to code, we need to understand the basic languages. As far as artificial intelligence is concerned, we start from Java, Oracle, Python. Python is very easy to learn these days. There's so many libraries involved. And using these languages, we can code, we can develop new technologies and techniques. And yes, we can master the skills of artificial intelligence. So talking about today's lecture, which is applications of artificial intelligence in optimizing dairy production, I will be discussing the basics. And based on those basics, I will be discussing which are the various technologies which are being developed in and around the country for dairy production, for optimizing dairy production, because dairy is being produced in stages, but optimal dairy production is the need of the hour. That we need more milk per animal. We need to increase the productivity of the animals, because if we talk about our country, we have the largest bovine base in the world. But as far as the production scenario is concerned, uh, we are lagging in that area. So what are the techniques how this artificial intelligence can help in boosting the dairy production? We'll be discussing in this discussion in this lecture. So before getting into what is artificial intelligence and its applications, let's understand few important terms. These terms are being used very frequently these days. Be it artificial intelligence, machine learning, deep learning, big data, IoT, blockchain, cloud computing, NLP. So, what actually, in very simpler terms, in very simpler words, I'll be explaining these terms. So, talking about artificial intelligence is nothing but anything, any information or any computation which is done by the help of software or computers. It may be a simple computer like calculator, it may be a high-end computer like supercomputer. So any information which is being processed by a software or a computer, it is called as artificial intelligence. Now there are two types of intelligence. One is natural intelligence, which is by the virtue of God, we humans are having. And the other is artificial intelligence, which the computers are having by the virtue of human beings, because we have created computers. Now, these are the two types of intelligence. One is natural and other is artificial. Artificial intelligence, it is a very broad term. Like like I said, that you start from calculators, you end up to supercomputers. So all the categories in between, they comes under artificial intelligence. And machine learning. Now, the second term, machine learning, is the subset of artificial intelligence. Anything which is learned by a machine, like what we do to a machine, we program a machine. And with the help of that program, if machine learns something and gives us the result, it is called as machine learning. Now, the simple example of machine learning is calculator. 2 plus 2 equals to 4. Now, a calculator, it can simply, what it does, it simply calculates that 2 plus 2 it is equals to 4. So this is uh, an example of machine learning. Okay, then deep learning is further a subset of machine learning. What is deep learning? Deep learning is when we need not to input any software, a special software into a machine, but it makes calculations on its own, like neural networks. Neural networks are the example of deep learning, whereby there are so many data points which are there to create a neural network. Once you have created a neural network, then it processes information on its own, like the neural network of humans. There are two types of neural networks. One is neurons. Human neurons, they are naturally made. But similarly, with the help of computer programming, by the help of programming languages like Python and using the softwares like Python, MATLAB, we can create neural networks, which are basically the algorithms. Computer softwares, which are basically the algorithms, and using those algorithms, the computer learns on its own. The software learns on its own and then gives us some result, and which is by the virtue of deep learning. Suppose if we want to predict anything, what we use is we use regression. Regression, we calculate to predict anything because we do have some data of the past. We apply regression models into it and then we predict the future. Similarly, the all the algorithms which are there, which we use in deep learning, they are basically derived from regression only. The mother equation is y equals to mx plus c. And based on this algorithm, we create more algorithms. And using those algorithms, when computer learns something and give us some prediction or give us some output, it is called as deep learning. Now, the next term is big data. As the name suggests, big data is basically a very big data. Okay, very big data means when we analyze our MBAC thesis or say PhD thesis, we have data of some, if I talk about extension scholars, we have some data of 100 farmers, 200 farmers, or 800 farmers. But big data pertains to thousands and lakhs and multiple lakhs of data. Like we may have data of thousands of crore of people, we may have data of thousands of farmers. Now, what is the utility of this big data? Now, if we are having data of say million farmers, it is not able, we will not be able to analyze that data A big data is basically a computer software which analyze that data, recognize the patterns, what are the patterns in that data, and gives us the result. For example, if there are say million farmers in India, now by the use of big data, we can identify that what are the major crops which are being sown by these farmers. Whereas if a human works on this million farmers, it would be very difficult for a human being to calculate or to analyze or to come up with the trend which are there in the big data. So here comes the importance of big data. Now coming on to the next term, which is Internet of Things. Now, Internet of Things, it is basically all the gadgets which are connected to internet, all the electronic gadgets which are connected to internet, they form uh, this technology called as Internet of Things. I'll give you an example. I am connected to you through my laptop, and you may be listening to me by your personal computers or laptops or your mobile phones. So my laptop, your mobile phones, and your personal computers all together they form Internet of Things. Why? Because all of them they are connected through internet and something functional, some functionality it is being carried on by the help of this what do you call this with the help of this Internet of Things. Now, giving you another example of Internet of Things, you know about Alexa. Alexa is basically a chatbot or a smart bot of Amazon. It's an Amazon product. You can connect many appliances to Alexa, and you just have to say, Alexa, start music, stop the fan, start the car. Why? Because all the gadgets they are connected to internet, and there is a common functionality of run and stop. This forms the basis of Internet of Things. Blockchain technology. Blockchain technology, it is basically a ledger, a digital ledger, whereby all the records, basically this is used to keep the records, and this is very important as far as livestock production or dairy production is concerned. Now, blockchain technology, it is basically a digital ledger whereby the records are kept, and records are immutable and indeletable. It means immutable means you cannot tamper with the records. And if you try to tamper with the records, then there may be a glitch, then may be an encrypted code which prevents the mutation or which prevents any change in that record, which is being kept by the use of blockchain technology. It is undeletable. Once you have kept any record using this blockchain technology, it permanently gets into the server of your supercomputer or the cloud database which you have created, and you cannot delete it. It will be there for the lifetime. It cannot be deleted. One example is I will be giving example in the coming discussion, but one example is the traceability. The traceability of food, feed, and other inputs which are required in dairy production. They can be channelized by the help of blockchain technology, and meeting with the adulteration, the purity can be ascertained by the use of this blockchain technology. These are the few examples, and I'll be discussing more in this discussion. Then cloud computing. Uh, Initially, when there was the very beginning of computers, there was a floppy, then came to the hard disk, hard drive, CDs, DVDs. What they are? They are basically the tangible storage devices. We can see it, and their capacity is very limited. Like your pen drive may be 2 GB, 16 GB, 32 GB, 64 GB. A hard disk may be 1 TB, 2 TB, 5 TB, 10 TB. Okay. A hard drive in a laptop, it may be 1 TB or 2 TB, it may be up to 5 TB. But as far as cloud computing is concerned, the space is unlimited. Now, talking about the real life example which you use everywhere is your Google Cloud, is your Gmail Cloud. Your data is there on your Gmail. It gives you an access of 15 GB for free, and after that, you have to purchase the space. This is what cloud computing is. All the data which is there on the cloud, all the data which is there online, and it can be accessed anywhere using any sort of internet device or any sort of Internet of Things. It is called as cloud computing. And if you see that all these things are very interrelated, artificial intelligence now, you see, it is a very broader term. And under that artificial intelligence, we have machine learning, we have deep learning, we have big data, IoT in which things are connected, blockchain, which is immutable and unrelatable. We have cloud computing on which everything which is there online available. So everything is interrelatable. You can use all the concepts together for creating a technology. And yes, when you take care of all these terms for creating a technology, it becomes very useful for the farmers. It becomes very useful for the stakeholders which are involved, be it dairy sector, be it any other sector. Okay, and last is natural language processing. Natural language processing is basically a speech recognition system in which whatever you speak, it is recognized by a software and then gives you the results. For example, the real life example which we use every day is your Alexa, Siri in mobile in iPhones. You have Google Assistant. You have Bixby in Samsung phones. So these are the examples of natural language processing, whereby something is said to a chatbot which is already there. Something is being said to a language processor which is there in your laptop, which is there in your phone, and then it recognizes your speech. It processes the words which you have spoken, and then gives you the desired results about what you are talking. Now, these are the very important terms which are to be known by the beginners, which or those who want to learn about artificial intelligence. Uh, I've already discussed about artificial intelligence, machine learning, deep learning, and there are different softwares which are being used using these various terms. This is very important. This data is of 2020, 1920. Now you see, if we see sector-wise artificial intelligence in India, the largest sector which is using AI is retail sector. Now, retail sector is what? Retail sector is Amazon. You are using Amazon, you are using Myntra, Flipkart, okay, and other your commodities, FMCGs, which you are purchasing day by day, which you are using day by day. So this forms the retail sector. This constitutes about 26% of the total AI used. Like these aggregators, the online aggregators, they were the first to use this blockchain technology. Like giving an example, like if you purchase anything on Amazon, so there's a time stamping of that particular commodity. Say it is starting from its warehouse in Mumbai. It suppose if you have ordered something sitting in Patna, so the commodity, it is lying in Mumbai. So what it does, first of all, the computer picks up, the robo picks up the commodity from the Mumbai warehouse, timestamps it when it will leave the warehouse. After leaving the warehouse, it will go to a certain godown, or say of transportation godown. It will get timestamped there. From there, it will go to warehouse which is located in Patna. It will get timestamped there on what date and time it reached that warehouse in Patna. And then from Patna, say if it is to be delivered at Basu, so it will reach Basu at certain point of time and date. So this is how this blockchain technology works, and this is how time stamping and dated works. So the first users of this AI blockchain technology, they were retail sector, Amazon and Flipkart, whereby the time stamping it took place, and we were able to get real-time updates about our commodity, followed by banking and finance. Now, banking, it is very important because every day, with the advent of UPI, uh, we use UPI in multifarious jobs. Like suppose, from rupee 10 to rupee 1 lakh, we can use that UPI and we are using it. There are millions of transactions which are taking place using this UPI. And then this big data comes into play. Like how many users, how many users are there which are using this particular UPI app? What are the accounts which are being credited and debited? So all this data, it is being recorded. All this data, it is being saved somewhere using the concepts of blockchain, big data. And this is how banking, it is using AI. Banking is also using AI with the virtue of natural language processing. Now you can go to, there are certain ATMs, you can go there and you can swipe your card and you can, with their voice assistant, you can talk to their voice assistant and then you can get your work done in the bank. Similarly, we have media houses, transportation, manufacturing, healthcare, but we are concerned with agriculture. Out of the total 100%, only 5% of the AI technologies, it is being used in agriculture. And this 5%, it includes the technologies which are being used in majority agriculture sector. And the technologies, AI technologies, which are being used in agriculture sector, they are drones. Now, drones, they work on the principle of image recognition. You have plucking robots, which works on the principle of spectrophotometry and image recognition. Then we have this sensors, this temperature, humidity sensors. We have smart irrigation systems. So these are the examples of AI technologies which are being used in agriculture sector. Very less are being used in dairy production in general, in particular, and livestock in general. What we are doing these days, we are, investing much into smart collars. Now, I'll be discussing smart collars in detail, but smart collars are the only one technology. Smart collar is the only one technology which is being majorly used in livestock production. Whereas the other technologies are concerned, they have their huge database in agriculture sector, but very less as far as livestock industry is concerned. Further, we'll be discussing about, as far as AI is concerned, we'll be discussing about technologies in livestock health, production, reproduction, marketing, statistics, and blockchain technology. Now, coming on to the applications of AI for livestock health. Now, I have used this general word livestock because dairy is a component of livestock, and we can use all these technologies in dairy as well. Now, there are certain scientists who are working for, generalizing these technologies in dairy sector. Few of the technologies, they are particularly for dairy sector, but there are few technologies which are field specific. Suppose they are being made for poultry or piggery, but they can be made for dairy as well. The first, talking about livestock health, the first technology is robo-imaging. We know that as far as the livestock health professionals are concerned, they are exposed to the fetal X-rays. Now, to reduce the exposure of X-rays to the veterinarians who are working in livestock health, Pennsylvania State University, they created one smart imaging system for taking radiograms, for taking X-rays of the animals. They're called as robo-imaging. And with this robo-imaging, there is no human exposure. And the robots can take the X-rays of the animals and they can tell whether the animal is suffering with lameness or any other. So this is one technology. We have simulators. The Cornell University in USA, they have created simulators for their graduating veterinarians. The veterinarians, they have to work on the simulators before practicing actually on the live animals. So they have to go on the simulators. They have created simulators for canine and calf management. And the graduating veterinarians, whether the small animal veterinarian, the large animal veterinarian, they have to clear courses on simulators first, and then they can go on actual animal. Then we have thermal imaging, infrared thermography, which is called as IRT. With the help of this IRT, we can, diagnose the diseases with precision. Like as far as mastitis is concerned, we know that this mastitis, it is having very huge economic impact. But with the help of this thermal imaging, what we can do is we can sense the increase in temperature of the udder, and we are successfully able to diagnose and treat subclinical mastitis as well. Because if we are able to diagnose subclinical mastitis, we can prevent the onset of clinical mastitis and major harm to the animal. Now we have reconstructive surgery, which is mediated by the robots. Like we know that there are, as far as the maxillofacial joint of the animals is concerned, it is of prime importance, and once it is gone forever, and no one can reconstruct it. But with the help of robots, we can now able to reconstruct very precisely the various parts of the animal body. And as far as lameness is concerned, as far as locomotor diseases are concerned, so it can be cured with the help of these reconstructive surgery. We have anti-stress ear tag. So now we have jumped on to smart collars, but the precursor of these smart collars, they are ear tags. So ear tags, they were implanted in the ear of the animal. They were able to sense about, they were able to give us information about the blood pressure, the heart rate, the temperature of the animal, the gases which are being produced by the animal. So all these things, they are being basically, the data regarding these things, they are gathered by anti-stress ear tag, and then they are able to give us precise information. The respiratory diseases, they are very important, and this respiratory disease package, it works on the principle of natural language processing. Like we know that this is the normal voice of the animal, and if animal it is suffering with any sort of respiratory disease, this respiratory disease package, it records the voice of the animal, and any deviation from the normal voice of the animal, then or an alert is given to the farmer that yes, your animal is suffering, maybe or tentatively will be suffering with a particular disease, and you can take the preventive measure. This is how this respiratory disease package it works. Now, coming on to the livestock production, there are many examples as well. So first is automatic feed manager. Like we know that as far as dairy production is concerned, we have animals in the various lactation states, in the various physiological states. There may be dry animals, there may be pregnant animals, there may be animals who are in the service period, there may be animals who are there having calf-fed foot. So based on the physiological status, based on the needs of the animal, and based on the commodities, based on the feed ingredients which a particular farmer is having, this automatic feed manager, it formulates the feed and then distributes that feed among various animals. Like if we know that the protein in the later stages of pregnancy, the higher protein is required, so it will formulate ration based on that protein level. If suppose a lactating animal is there, if it needs more metabolic energy, so it will create ration based on the amount of metabolic energy a particular animal is required. Now, 3D cameras are basically used for beef cattle, not as far as Indian conditions are concerned. Milk in the goats or the buffaloes, they can be uh, graded, or their body conditioning score can be graded by the use of 3D cameras, because it tells us about the conditioning of the animal, whether the animal it is lean or whether the animal it is fat. So based on the pictures which are taken, uh, 3D cameras, they take the pictures, then by the help of convolutional neural networks, which is basically a software based on machine learning, it analyzes those pictures and gives us the result that yes, this animal is lean or this animal is fat. So based on the alerts which is provided by the computers, we can change the ration of the animals to bring them at a desired goal. Now we do have robocams. Robocams are initially developed for large poultry houses, whereby we have millions and millions of birds with us. Because when you have large poultry houses, a farmer may not be able to, keep a strict vigil on all the birds. So robocams, they were developed for that reason. But nowadays, the robocams, they are used for large farms to check the various diseases in the farm, uh, and also in large dairy farms and goat farms. Now we have virtual fences in grasslands and ranches where there are large number of animals and very less number of people. It is not feasible for the people to take care of a very all the animals. So there the virtual fences, they come into play. They works with the global positioning system GPS. They have GPS tracker into that, and with the help of these virtual fences, we can restrict the movement of the animal to a particular plot of land where we will let that animal to graze. And if suppose the animal is going to some other plot or to some other grassland or to some other ranch, we can, with the help of a very small of the animal to the desired place. About the fodder and feed condition in the country, we say that there, as far as green fodder is concerned, we are 30 to 40%, up to 30% deficit in green fodder production. We have deficit in green dry fodder production as well. So keeping these concerns in mind, there are smart hydroponic systems which are basically uh, uh, practiced with or which are basically practiced under this green nets or the poly houses which we have, wherein with the help of computers we can monitor the temperature, the humidity, the irrigation systems, and these hydroponic systems, they can prove to be very useful for providing year-round supply of green fodder to the dairy animals. Now we have export systems whereby we have different uh, softwares which are available online. There's different softwares which are available in the form of mobile apps. We can put in uh, the data of our animals, and based on the data which we have input in that particular device, it provides us with a valuable output and tells us that this particular animal may come to heat in this particular month or date, and then we can go for the AI. This particular animal parturited on this date, and now this amount of this amount of feed is required or vaccination is required. For keeping track of all the records of the animal, this expert system, it is of prime importance. Uh, this area, as far as dairy production is concerned, it is very important. Livestock reproduction is very important because the production is based on reproduction, or you can say that these are interchangeably related to one another. Until the animal reproduces, it cannot produce. So in order to gain optimal reproduction, we have to ensure the optimal reproduction, the timely reproduction in the animal. There are thousands of crores of rupees lost if we skip a single heat in the animal, talking about the complete livestock which we have in the country. Now talking about smart collars. So smart collar and smart pedometers. Picture number 1 and picture number 6. I'll be explaining them jointly because they are one or the other way related to one another. Smart pedometers, they are basically worn on the feet or the hoof of the animal, over the hoof of the animal or the fetlock, or on the shank. Smart collars, they are tied in the neck of the animal, but the principle, the working principle is same. Smart collars, they are basically sensors which consists of accelerometers. Accelerometers are there in our phones as well, which tracks the daily movement of our body, or which tracks the daily footsteps which we have walked. Similarly, there is an accelerometer which is there in the smart collar. Then there is one a transmitting device. A transmitting device, it may be a Bluetooth, it may be a Wi-Fi antenna. So generally Bluetooth, it is cheap. So Bluetooth is being used. Then it consists of a battery, which is being used to take care of all the semiconductors which are there, or all the sensors which are there engraved onto the motherboard. We can use gas sensors for accessing how much gas it is being produced by the animal. We can use methane sensors, we can use carbon dioxide sensors, we can use sulfur sensors. uh, uh, we can use thermal sensors for recording the temperature of the animal. We have smart watches which records our blood pressure, which records our heartbeat. Similarly, all those sensors, they can be implanted on the motherboard, and they can be tied around the neck of the animal. And there are smart collars now which are being developed, which can give information about 70 to 75 various parameters inside the dairy farm and of the animal body. This is one device which is being excessively used in the dairy industry. Why? Because initially the cost of smart collar, it was high, but nowadays the various companies, the various tech companies and the startups, they have started producing smart collars with the help of what, with the help of which which we are able to reduce the cost of these smart collars. Uh, Talking about the various technologies which are being used in uh, dairy industry, smart collars are one of the cheapest technologies. Like cost, it varies from 3,000 to 5,000 with integrated software of 1 to 5 point, from 1 lakh to 1.5 lakh. Whereas other technologies, they are quite costly. Smart collars, they are quite cheap comparatively, and the large dairy farmers, they can adopt it very easily. Uh, Face recognition, again, this is based on convolutional neural network phenomena, whereby the faces, they are being captured, and we can keep record of the animal. Now this animal has been in heat and it has been inseminated. This animal is producing this much amount of milk, and nowadays the Pashu Adhar, it has been created, and it was uh, the muzzle imprints. They were taken as a part of biometrics. As far as Pashu Aadhaar is concerned, it was a part of this face recognition technology. A gait analyzer, again, it is a camera-based software which are developed using convolutional neural networks, and it can give us information about the lameness in the animals. We have smart apps which can keep records and provide us with the real-time results and real-time analysis reports. We have smart calculators which provides us similar results as far as smart apps and expert systems are concerned. And smart pedometers are just like smart collars, giving us information about uh, the estrus detection. How estrus is detected by the use of smart collars is, like I already told you, that there are pedometers. They keep a record of the footsteps or the movement of the animal, and we all know that when the animal comes to eat, the number of footsteps or the movement in the animal, it increases. And based on that data, on the previous data we and the algorithm which we have created, it analyzes the data on its own and tells us precisely that this particular animal will come to eat on this day of this month, or this animal is in heat and it needs to be inseminated as of now. Uh, Now we have applications for production marketing, in countries like Netherlands and New Zealand. Australia, in US, and also in Poland and Norway. These systems are currently being used by the large dairy farmers. They have thousands of animals with them. Automated milking booths, milking robo, milk cooling system, and smart packaging. So all these technologies, they are related to one another. Like they forms a complete chain. Like if I talk about automated milking booth or milking robo, what it does it, uh, the animals, they have their collars with them. So animal, it enters the milking parlor. There are robos which let the animal into the milking parlor. Then with the help of robo arms, the milking cup, it is attached to the teats of the animal. The animal is milked. Then animal is giving it is given a bite, which is basically a reward, and based on that reward, the animal, it comes again and again. Now the smart collar, it is basically, it also have an RFID device, which is the radio frequency identifying device. Similarly, uh, you know our fastags. It is similar to our fastags which are there on our vehicles. So this one robo at the entrance of this milk booth recognizes that RFID which is there with the animal and lets the animal or pushes the animal away. Suppose if the animal, it has been already milked, that again, if that animal comes into the milking booth, it will be shooed away at the entrance only. But if the animal, it is coming late, it will be let in, and then a reward is given in the form of a bite to the animal. Then with the help of this milking robo, the udder of the animal, it is washed, it is sanitized, then the teat cups or the milking cups, they are attached to the teats of the animal, then the animal is completely milked, and automatically the milk goes to the milk cooling system or to the pasteurization chamber, and then again it goes to the smart packaging assembly where the packaging of the milk takes place, and all this complete process of milk marketing or this milk packaging, it takes place without human touch. Uh, we have applications of AI for livestock statistics. We have Vettel's diagnosis, which uh, on which is based on convolutional neural network, and it analyzes the various pictures or the radiograms which are being obtained, and it tells us, it aids the veterinarians in arriving at a precise diagnosis that animal is suffering with what locomotor disease. We have vet computing software, Sophie, Google DeepMind, Deep Genomics. It helps in keeping records, analyzing the data, analyzing the genetic and breeding data of the animal, making predictions about milk production, making predictions about the breeding values, and the various other parameters related to production and reproduction in the animal. Okay. Now, this technology, this blockchain technologies I was talking about, it is basically a digital ledger. Now, suppose, giving you an example of a ledger, this is what a ledger looks like. Now, suppose if I talk about a cattle house or a cattle barn or a dairy farm. So in 76, suppose it was sold to owner one. It was in 1980, it was improved. 1980 extension was approved. So this is a digital ledger which may be, kept for a dairy farm. But the owner of the dairy farm, it can, you know, what it can do, it can delete any entry in that ledger. Like if a dairy farm failed inspection in 1992, it can be deleted. The entry number 5, it can be deleted in a ledger. Whereas, this blockchain ledger is concerned, or blockchain technology is concerned, whenever we create any entry in a blockchain, a new code is formed and it is encrypted. Now, this encryption is basically a key. It is a one-way traffic. You cannot come back, or you cannot come back to delete any entry in that blockchain. Uh, if you try to delete any entry in a blockchain, you need to de-encrypt the code. And once the code, it is de-encrypted, the person who deals with the blockchain, it gets to know that yes, at this point of time, that something has been done with the code. Someone has tried to de-encrypt the code, and, which is basically an alarm for the stakeholders which are using this technology. And this particular technology, it forms a block. Now, block is what? block is basically data, a block of data. Now, when we combine the blocks of data together, it forms blockchain. And every block, it is secured by a key, which is basically an encryption code, or which is basically an encrypted code. Now, how this blockchain and dairy or livestock it works, like every step, at every step, this blockchain can be this blocks of data it can be built, be it data related to reproduction in a case when the animal it came to the heat, or starting from the very beginning when this particular animal was purchased, and after purchase when this animal was when it initially parturited, how many kids, how many calves or male or female calves they were born out of this particular animal, what was the milk production of this animal throughout its lifetime, what was the lifetime milk yield. So all these blocks of data, it can be created, or it can be kept, or it can be secured by the help of this blockchain. And like the breeders and the geneticists, they can use this technology for making precise this predictions about the milk yield or any other genetic or breeding parameter of the animal. Now it helps in understanding the net worth of the animal. What was the worth of that animal? What will be the worth of the calves which will be born out of this animal? And then it will help in decision making. That whether the progeny of this animal is to be kept in the farm, or it is to be culled from the farm. So this way, blockchain it can be of immense help. Uh, Now, how blockchain it helps in other forms is it can strengthen the input supply chains. Now we know that there are problems of the batches of the vaccines they gets discarded, or there are batches of vaccines which malfunctioned, or the efficacy was not there when they were tried in the field conditions. So the blockchain technology it will help us in understanding that at what point of time this particular vaccine it was manufactured, what was the batch number, and from there, which was the part of the planet where it landed, and then the complete supply chain or the cold chain it can be understood with the help of this blockchain technology. Similarly, with the help of medicine, it can be done. The substandard or the degraded medicine it can be checked with the help of blockchain technology. Precise weather prediction and forest production it can be done with the help of blockchain technology, that the predictions can be made that what will be the amount of rainfall which will be there in the monsoon season, and based on the data from the meteorological department or from any other concerned department, the farmers they can sow the forage and make up with the nutritional demands of the animal. Similarly, the vaccine production and medicine production it can be taken care with the help of uh, tracking diseases. It is one of the very important features of this blockchain technology, because as far as disease occurrence is concerned, animals are related with the disease occurrence, and if we are having precise data of the animal, we will be able to predict that suppose if there now the monsoons have been set up, there may be the chances of FMD, there may be chances of hemorrhagic septicemia, there may be chances of mastitis, or as far as goats and sheep are concerned, there may be chances of foot rot in that small ruminants. Uh, by the use of this blockchain, we can trace livestock-based harmful foods, because we know that milk, as far as milk is concerned, this is a highly perishable commodity, and within 1 to 2 days, the milk should reach to its intended users or the consumers, other than the UHT milk. And based on the time stamping, we can check that what was the date of manufacturing, what was the date of pasteurization, where was the plant located from which this milk has been originated. Again, livestock feed safety, it is one of the major concern. It can be taken care with the help of blockchain. Uh, I'll be explaining with example in the coming slide that how this particular blockchain technology works, as far as the inputs are concerned or the commodities are concerned. With the help of blockchain technology, what we can do is we can timestamp the produce. Like suppose if I talk about maize, from which farm the maize has been procured by the feed manufacturing plant, at what time it was procured, at what time it reached the plant, at what time it was processed into a feed, at what time this particular feedback it left the plant to a warehouse, and from the whole chain of wholesalers, retailers to the end consumer, there are always a timestamp, and farmers they can get to know about the livestock feed, and it also gives information about the stale feed and the adulteration of the feed. Again, as far as livestock waste is concerned, there are certain systems of the software which are being developed elsewhere on the planet, uh, and the people they are gaining or they are getting money after selling this livestock waste, because we know that as far as livestock waste is concerned, this is of prime importance because we can easily convert it into manure and use into our agriculture fields. And as far as our neighboring country China is concerned, they have developed a software whereby the farmers they are providing uh, the manure or this livestock waste to a particular company. The company is making biogas or compressed biogas, and then converting the CBG compressed biogas into electricity and supplying it to the dairy farms. In return, what farmers are getting is they are getting cryptocurrency, or they are getting coupons, and which can be easily exchanged for money, or it can be easily exchanged for electricity if they want to purchase from the grids. So this is a system which has been developed in China using this blockchain technology. The farmer they can, if the farmer they are not having any infrastructure related to waste management, what they can do is they can directly sell the produce to a company who is manufacturing, who is generating electricity from the livestock waste, and based on the coupons which they get in return, they can again purchase electricity from that company. So this is one system which is being prevalent. uh, this is permission blockchain. Like now I would like to uh, I'll explain a little bit more about blockchain in dairy industry, or blockchain in milk production, how blockchain will help in prevention of milk adulteration, or in prevention of adulteration of any other dairy products. uh, why milk production is important? Because milk is the highest grossed agriculture commodity in the country, and we all know that whatever we are producing, we are utilizing the same. uh, Quality assurance, as far as milk is concerned, quality insurance is of prime importance. We are not gaining exports to the level what New Zealand or Netherlands or any other milk producing country it is gaining. Why? Because our quality is at stake. We should we are still focusing on quantity but not on quality. Whereas this blockchain technology will help us in ascertaining the quality of milk production. Now, how this particular this blockchain it works? Suppose a dairy farm, it is having 10 animals. Now, all those 10 animals, they may be milked with the help of milking robots or with the help of milking machines. Now, when we are milking that particular animal with the help of milking machines, the milk comes to a common processing facility. When that milk comes to a common processing facility, before that, there may be a component of the blockchain which tells us about that particular dairy farm, that this dairy farm has 10 number of animals. The average production of this dairy farm, it is 100 liters. Now, if that dairy farm, it produces, say, uh, produces milk which is not in the range of the data which is there for, say, year or 2 years, then there may be a red flag associated with the dairy farm. It means if suppose the production of the dairy farm it is 100 liters, but the particular dairy farm it is producing 140 liters, it means that there is a component of adulteration in that particular farm. So there's a time stamping. So there may be a time stamping of that produce over that particular farm. Now that milk, it reaches to a processing facility, and again, if there is an iota of doubt that particular processing facility it is dealing with adulteration, or if it has adulterated something, then again it will be a red flag for the consumers. Now, with the help of this time stamping, what consumers can do, they can go back to the time, okay, and they can uh, trace that this particular milk it has arrived from this particular dairy farm, then it went to this processing facility, and then again this processing facility to this particular wholesaler, and then retailer, and then to the common supply chain what they are having. So just with the help of this timestamp, a consumer can understand that whether there was adulteration in their particular commodity or not. So this is how a permission blockchain it works. Now talking about the precision livestock farming, it is basically a concept which deals with all the application or the concepts of artificial intelligence which I have developed in this particular discussion. It consists of biosensors, it consists of big data, blockchain, the scholars, early disease monitoring systems or the early disease surveillance systems. So all these sensors, when come together, they generate some data, they analyze that data and gives alerts to the farmers that forms the pool of precision livestock farming. And this is on itself, it's very important for the farmers to optimize their milk production. So this is all from my side. If you're having any sort of question related to my talk, you can please ask.
Okay, thank you, Dr. Amandeep, for such a nice and informative lecture with a very beautiful presentation. Now the session is open for the discussion. Participants are encouraged to ask the question. Participants, you can ask directly or you can write in the chat box for any query. Okay, if you don't have any query, then on behalf of organizing committee, I would like to thank Dr. Amandeep for such a very informative lecture. Sir, you have elaborated the application of AI in a different sector like marketing, application in the livestock production, reproduction, products marketing, and how we can manage the livestock waste using the AI very nicely. Participants, have you any query? Okay. I think we don't have any query. Then thank you so much, sir, for this nice lecture. And at last, I want to thank all the participants for their active participation. Participants, we will meet at 2:30 p.m. for our next lecture.